How magnets grab iron. Why does a magnet grab iron but ignore wood and copper? In energy filament theory, F, the answer lives in how easy the road is in the energy sea. F says the universe has two kinds of slope. One is a tightness slope, where the sea is pulled more tight, you slide that way. That is what we call gravity. The other is a texture slope, where the lines in the sea run more smooth and straight. Motion likes to follow those lines. That is what we call electric and magnetic force. Magnets use the second kind. Remember the earlier picture. Inside each electron, energy runs round the ring as a ring current. That ring current leaves a tiny swirl in the sea, a magnetic moment. On its own, that swirl is very weak. But in a magnet, huge numbers of electrons have their swirls lined up the same way. It is like a field of wheat where every stalk leans the same way in the wind. When that happens, the sea inside the magnet gains a long, smooth texture lane, a path where the pattern is far more tidy than in the space around it. So why is iron special? In iron, some electrons are free to twist their swirl and match the swirl inside the magnet. When the magnet comes near, those electrons in the iron feel a small turn and click into the same way. As more of them line up, the sea between magnet and iron grows a single, joined texture lane. On the near side, the road in the sea is smooth and straight. On the far side, it is broken and bent. That means, inside and around the iron, there is now a slope from hard road to easy road. And the easy road points toward the magnet. It takes less effort for small jostles in the sea to move the iron that way than to move it any other way. So tiny pushes from the restless sea keep nudging the iron toward the magnet. To us, it looks like the magnet pulls the iron in. Think of wind over grass. Each blade does not pick a way to lean. But if the air moves more smooth in one way, the grass will all bow that way. Iron does the same thing. It does not want the magnet. The sea around it simply makes it much easier to move into the smooth lane than to move out of it. Wood or copper do not line up their tiny swirls in the same way. Their wheels never sit on that track, so they do not get carried along. The two ends of the magnet are just the ends of that texture lane. Where the swirl lines go in, we call it the South Pole. Where they spill out, we call it the North Pole. Next episode, why spin is not a little ball turning in space. Tap follow, share it on New Physics, Clear Universe.